Hey, it's been a while since we've done this, so I hope that you are ready to get into some radicals, aka square roots. First thing, I noticed that a lot of you are struggling with the difference between square and square root. Those are two completely different things. These numbers right here are square roots. These numbers here are squares. And it may even be a good idea to copy this whole table because you need this list right here and maybe even a couple more so you can get used to these squares and square roots and memorize them. Alright, so if we see square of 16, that means 16 times itself, right? Okay, so what we end up getting when we do that, I believe, is 256. Let me double check that. Yes, that is 256. So this is the square of 16. Now, when you see the square root of 49, that means you're taking the little symbol 49. And what that ends up giving you is 7, but remember that we can square a positive or a negative 7. So this would be plus or minus 7. Okay? Alright, now it's really important that you know the difference between those two words. So when we look at this, finding square roots, don't forget this little bit of information right here. 5 times 5 is a positive 25. Negative 5 times negative 5 is a positive 25. And they are the same answer. Okay? So finding square roots, we're looking for two numbers multiplied together. So we're finding the square root of 36. So this means we are taking the square root of the number, which means it's 6, but it's positive or negative. Now we move on to the next one, 81. Now remember, we're taking the square root of 81, and that would be 9, but again, positive or negative. And then our last one, when we're taking the square root here. Now because it's a fraction, you take the square root of the top, so square root of 100, and divide it by the square root of the bottom. Okay? So we end up with 10 on the top over 9 on the bottom, and then we put our plus or minus there. Because if you remember, when you multiply fractions, just to continue this one, when you multiply fractions, 10 over 9 times 10 over 9, you multiply straight across, which would give you 100 over 81, which is exactly what we started with over here. And again, if we did negative times another negative, well, we know that a negative times a negative is positive, so we end up again with the same answer. Okay? All right. Smooth sailing so far, huh? Now finding squares. So if this says find the square of each number, what that actually means is we are taking 36, multiplying it by itself. Okay, so we take that 36, square it, and we get 1,296. This is the square. All right, now here, 81. That means 81 times 81. And when we do that, we end up with 6,561. So this would be your square. Now with this one down here, squaring means multiplying by itself. So 100 over 81 multiplied by 100 over 81. So when we multiply the top, we get 1, and then we have the 4 zeros. Oops. And then when we, of course, square, oops, that's only 3 zeros. Whoops, there we go. 4 zeros. And then when we square 81, which we did right here, 6,561. So this would be your answer. Of course, if we can simplify, we would, but for now, I just want you to know the difference between square and square root, because a lot of you will get in this habit of seeing the number 4, and so you automatically do square root and say, oh, well, it's 2. But if the question is asking you for the square, it is not, the answer is not 2, it's in fact 16. So pay very close attention to the wording. All right, the wording is really super important. All right, now simplifying radical expressions. Okay, now you're probably thinking, what in the world is radical? Well, that would be why I gave you this little figure, or this picture, because radical is exactly the same thing as a square root. Okay, those two terms are totally interchangeable. They are the same thing. Okay, so first thing you're going to do, step one, look for a perfect square that goes into the number evenly. Now remember back here we talked about perfect squares. They were right here, 1, 4, 9, 16, and on and on and on. And you may want to write down that these are called perfect squares, okay? So when we're looking for a perfect square that goes into the number evenly, let's say we start with something simple. Let's say we start with 32, okay, and we want the square root of 32, and this is just an example. Now, we're looking for two numbers that will multiply to give us 32, where one of them is a perfect square. Well, we know that 4 would go into 32 evenly, right? 4 times 8. And we know that 4 is a perfect square. So this one right here is a perfect square. But then we want to check and see if maybe there's something higher. What else? What's the next perfect square? 9. 9 doesn't go into that evenly. How about 16? Well, 16 does. It would be 16 times 2 would give you 32. Okay? So now that we have found this right here, and it's the biggest possible perfect square, we're going to go on to step 2. Rewrite the number under the radical as a product of the number from step 1 and what's left over. So instead of having the square root of 32, this now becomes the square root of 16 times 2. Okay, so it's the same thing. It's still 32. Our step 3, we're going to take the square root of the perfect square. So we're going to, I'm just rewriting this whole step again. So we had square root of 32. We broke it down into the square root of 16 times 2. And then we're taking the square root of the perfect square, so this one. And if you want, you can even split this up to be the square root of 16 times the square root of 2. And we know the square root of 16 is 4. And then we have the square root of 2 left over because this is not a perfect square. And then of course we have our plus or minus because we are, or I'm sorry, no plus or minus, because we're simplifying, not solving it. So if we're only simplifying, its sign is whatever is right here. Okay, so there is no negative sign, so it's only your positive answer. And like I said earlier, you want to make sure that you take out the highest perfect square that goes into the number. If you haven't, then you want to repeat the above steps, and I will show you an example, and actually the same one with 32. I'll show you how to do it if you didn't take out the perfect square, highest perfect square to begin with. Okay, so here are some examples. We'll go ahead and do a couple of these together. Let's say I had something like the square root of, or sorry, let's start with that square root of 32 again, okay? We broke it down into, we know that factors, so some of the factors of 32 would be 4 and 8, 16 and 2. Okay, sorry about that. I had to get my door. Okay, so we originally said that 32 is the same as saying 4 times 8, right? Okay, so if we follow those steps, we replace it. So we put under the square root 4 times 8. We split it into two radicals, so square root of 4 times the square root of 8. We take the square root of the perfect square, which would be this one, to give us 2 times the square root of 8. Now you notice that this is not the same simplified answer as what we got over here. So what you need to do is make sure there are no other perfect squares that will go into 8. Well, 8 is 4 times 2, right? And 4 is a perfect square. So we're going to repeat this process, but only with this number. So we're keeping this 2 on the outside as it is, and instead of having 8 under there, we're going to do 4 times 2. We can split that into the square root of 4 times the square root of 2. Now when we take the square root of 4, we get 2. And remember that this is all multiplication right here. So this just becomes 2 times the square root of 2, or simplified, 4 times the square root of 2. And there's our answer, simplified, and it matches our previous answer as well. Okay, so let's go ahead and do another one before we move on. Let me get rid of this. And our next example, our number 2, I will do, let's say, the square root of 153. And I want you to simplify it. Okay, well, first thing you have to remember, this takes a lot of trial and error. You'll probably sit with your calculators for a while doing 153 divided by 4, 153 divided by 9, 153, blah, 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 and keep going till you find one that works. Well, in this case, it actually will split into 9 times 17. And remember, we split that up, square root of 9 times the square root of 17. Square root of 9 we know is 3, and then we have the square root of 17. Alright, now 17 we want to see, are there any perfect squares that go into 17 evenly? Well, 17 divided by 4, no, because 4 does not go into 17 evenly. Then we have 17 divided by 9 would be our next one, and that doesn't work. And then our next would be 17 divided by 16, and that also does not work. So this 17 right here is simplified as much as it can possibly go. And there is your simplified version of your first problem. Okay, now, multiplying radical expressions. So multiplying numbers with radicals. Basically, we're just going backwards. If you look back at these examples that we did right here, we split these two into the square root of 16 times the square root of 2. But it originally was underneath the square root together. So all you have to do is just multiply the two numbers. So if we had something like the square root of 10 times the square root of 5, this would mean we have the square root of 10 times 5, which is the square root of 50. But now we want to simplify, always simplify. So we take that square root of 50, and we want a perfect square that goes into it evenly. Well, 25 times 2. Alright, so now we split that into square root of 25 times the square root of 2 to become 5 square root of 2. And this would be your simplified version of this answer, or this original problem. Okay, so we multiplied them under the square root, put the number here, and then we simplified. 25 is the perfect square. 25 times 2 gives you 50. Split them, took the square root. Now if you have something like 3 times the square root of 2 times 7 times the square root of 5, multiply your outside numbers. Remember that this is all multiplication. Actually, let me just show you. 3 times the square root of 2 times 7 times the square root of 5. Well, I can use that commutative property and write it as 3 times 7 times the square root of 2 times the square root of 5. Sorry about the interruption. Just deal with it. So now we multiply 3 times 7, 21, and then square root of 2 times 5. So we get 21 times square root of 10, which is simplified. There is no perfect square that goes into 10 evenly. Ta-da! You're getting smarter. Can you feel it? Well, you know what time it is.
Go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.